The simplest composition is just combining a prompt and a model to create a chain that takes user input, adds it to a prompt, passes it to a model, and returns the raw model. You can mix and match prompt template, chat prompt template, and LLMs or chat models as you like here. Oftentimes, we want to attach KWR that will be passed to each model call. Here are a few examples of that. For example, attaching stop sequences or attaching function call information by defining the list functions, the chain variable, and calling the method invoke. We can also use the prompt template plus LLM plus out parser. We can also add in an output parser to easily transform the raw LLM chat model output into a more workable format. Notice that this now returns a string, which is a much more workable format for downstream tasks. Functions out parser. When you specify the function to return, you may just want to parse that directly. Simplifying input. To make invocation even simpler, we can add a runnable parallel to take care of creating the prompt input for us. Since we're composing our map with another runnable, we can even use some syntactic sugar or just use a dictionary. We can also add in a retrieval step to a prompt and LLM, which adds up to a retrieval augmented generation chain. We first import all our classes, define the vector store, the retriever, the template, prompt, the model, build the chain, and then call the method invoke on the chain. We can also define another template and the prompt, build the chain, and again call the method invoke. For a conversational retrieval chain, we can easily add in conversation history. This primarily means adding in chat message history. Once again, we do our import, we define the underscore template, the condensed question prompt template, and the answer prompt, as well as the default document prompt. We create a method for combining the document, we define the input and the contact, we build the conversational Q&A chain, and we call the method invoke on the conversational Q&A chain to obtain our output. With memory and returning source document, this shows how to use memory with the above. For memory, we need to manage that outside at the memory. For returning the retrieved document, we just need to pass them through all the way. We do our import, we define the memory, the loaded memory, the standalone question, the retrieved document, the final inputs, the answer, and we build the final chain. We call the method invoke and we obtain the result. We can also use the method save contact on the memory as well as the method load memory variable, and we can see the history output. Once again, we can redefine the input, call the method invoke again, and obtain the new result. Now let's discuss about multiple chains using the LangChain Expression Language. Runnables can easily be used to string together multiple chains. To do this, we can import item getter from operator. We can also import the classes chat OpenAI, chat prompt template, and str output parser from LangChain. We define prompt 1, what is the city person is from, and prompt 2, what country is the city curly brace city in, respond in curly brace language. Then we define our model, chat OpenAI, object in. Then we build chain 1 from prompt 1, model, and str out parser in. Then we build chain number 2 as a dictionary with the keys city, language, city and language, vertical bar prompt 2, vertical bar model, vertical bar str output parser instance. And then we can invoke chain 2 providing the person Obama and the language Spanish, and we'll obtain our answer in Spanish. We can also import runnable pass-through from LangChain for runnables. We define prompt 1, generate a curly brace attribute color, return the name of the color and nothing else. We also define prompt 2, what is a fruit of color, curly brace color, return the name of the fruit and nothing else. Then we define prompt 3, what is the country with a flag that has the color, curly brace color, return the name of the country and nothing else. Then we define prompt 4, what is the color of the fruit, curly brace fruit, and the flag of country, curly brace country. We build our model parser as model, vertical bar, str output parser. We define the color generator as a dictionary with the key attribute, vertical bar prompt 1, vertical bar dictionary with the key color. We define color to fruit as prompt 2, vertical bar model parser. And we define color to country as prompt 3, vertical bar model parser. Finally, we define the question generator as color generator, vertical bar dictionary with the key value for fruit and country, vertical bar prompt 4. Finally, after we build the question generator, we can call the method invoke by passing the parameter worm, and we'll get a chat prompt value object with the messages, human message with the content, what is the color of a strawberry, and the flag of China, and the example attribute set to false. We can store this in the variable prompt, and then we can call the invoke method on the model itself by passing the prompt variable, and we'll obtain an AI message with the content, the color of an apple is typically red or green. The flag of China is predominantly red with a large yellow star in the upper left corner and 4 smaller yellow stars surrounding it. Branching and merging. You may want the output of one component to be processed by 2 or more other components. Runnable parallels let you split or fork the chain so multiple components can process the input in parallel. Later, other components can join or merge the results to synthesize a final response. This type of chain creates a computation graph that looks like the following. Input, branch 1 and 2, and finally the 2 branches will be joined together in a combined operation. The way this looks like in code is like this. We first define our planner using the chat prompt template, the chat OpenAI instance, the str output parser, and finally a dictionary with the base response. We also define the arguments for a variable using the chat prompt template, the chat OpenAI instance, and the str output parser instance. Then we define the arguments underscore against variable by using the chat prompt template, the chat OpenAI instance, and the str output parser instance. Finally, we define the final responder variable using the chat prompt template, the chat OpenAI instance, and the str output parser instance. And we also define the chain using the planner, a dictionary containing results 1, results 2, an original response, keys, and then the final responder. We then call the invoke method on the chain variable by passing a dictionary with the key input and the value scrum. This will return the following text. While Scrum has its potential cons and challenges, many organizations have successfully embraced and implemented this project management framework to great effect. The cons mentioned above can be mitigated or overcome with proper training, support, and a commitment to continuous improvement. It is also important to note that not all cons may be applicable to every organization or project. Regarding querying a SQL database with the LangChain Expression Language, we can replicate our SQL database chain with Runnable. We import the chat prompt template from LangChain prompts. We define our template variable and then our prompt variable using the from template method of the chat prompt template class. We import the SQL database class from LangChain utilities. Then we'll need the Chinook sample database for this example. We define the DB variable using the from URI method of the SQL database class. We define our get schema method and our run query method. Then we import the chat OpenAI, the str output parser, and the runnable pass-through classes from LangChain. We instantiate our model variable and we build our SQL response chain using runnable pass-through, the prompt, the model.bind method, and the str output parser instance. We can call the invoke method on the SQL response variable by passing the question how many employees are there, and we'll obtain as output the SQL code select count star from employee. In another example, we can simply define another template, create the prompt response variable using the from template method from the chat prompt template class. We build our full chain using the runnable pass-through, prompt underscore response, and the model. And finally, we can call the invoke method by passing the question how many employees are there, and we'll obtain an AI message object with the content there are 8 employees. Regarding agent, you can pass a runnable into an agent. You need to import the agent executor, the XML agent, and the chat anthropic classes. We define our model using the chat anthropic class by selecting model claude2. We define our search method, the tool list variable, the prompt variable using the XML agent class to get the prompt to use. Then we define the convert intermediate steps method, which contains logic for going from intermediate steps to a string to pass into model. This is pretty tight to the prompt. Then we define the convert tools method, which provides the logic for converting tools to string to go in prompt. Building an agent from a runnable usually involves a few things: data processing for the intermediate steps, the prompt itself, the model, and the output parser. Regarding data processing for the intermediate steps, these needs to be represented in a way that the language model can recognize them. They should be pretty tightly coupled to the instructions in the prompt. The model should be complete with stop tokens if needed, and the output parser should be in sync with how the prompt specifies things to be formatted. We then define our agent by first defining a dictionary with a question and intermediate steps keys, both pointing to lambda functions as their value. Then we use the vertical pipe to an invocation of the partial method of the prompt object, which then pipes into an invocation of the bind method of the model object. And finally, we have the get default out parser method invocation of the XML agent class. We instantiate our agent executor by calling the agent executor constructor and passing the agent, the tool list, the agent, and the tool list. Finally, we call the invoke method by passing the question what's the weather in New York to the agent executor, and we'll obtain the following result: entering new agent executor chain, tool search, tool input weather in New York 34 degrees, final answer the weather in New York is 34 degrees, finish chain. If you've enjoyed this video so far, it will really help me a lot if you subscribe to my channel by clicking the subscribe button and hitting the notification bell. I know most of you are not subscribed already, so you might miss out on any future content that I will release on this channel. Please subscribe today. Thank you. I recently created a Patreon account for the data science channel. At the moment, I create my videos in my spare time while also working a full-time job. Having a Patreon would allow me to receive donations from people like you who have enjoyed the videos that I've produced so far, and will help me improve the quality and the frequency of the videos that I post on the channel. Moreover, for each of the membership options available, I will provide some extra services for those of you who decide to support me. Essentially, you can pick between 3 tiers of membership. In the associate tier, you can provide me with the equivalent of a cup of coffee. I would provide you with all the materials and the code that I use during my videos, and with a monthly live session with myself where you can ask questions and we can discuss various topics related to data science. If you want to support me even further, you have the senior data scientist tier, where I'll also provide you with monthly one-on-one sessions with myself, where I'm going to provide you with guidance, mentorship, and answer any questions regarding your data science journey. Finally, for those of you who are more generous, you can opt for the lead data scientist tier, where I'll be happy to provide weekly one-on-one mentorship sessions, and as a bonus, I'll produce a 1-hour-long tutorial about the data science topic of your choice once you've been a member for 12 consecutive months of the lead membership. Each higher membership will contain all the benefits of the previous membership tier. So for senior data scientists, you'll also get the benefits of an associate data scientist, and for a lead data scientist, you'll also get the benefits of an associate and senior data scientist. I would definitely recommend you to consider supporting me in this journey. And the dictionary return will contain the question, what's the weather in New York, and the output, the weather in New York is 32 degrees. Regarding code writing, here's an example of how to use LangChain Expression Language to write Python code. We import the chat OpenAI, the chat prompt template, the str output parser, and the Python REPL classes from LangChain. We define our template, write some Python code to solve the user First problem, return only Python code in markdown format. Example, Python. Then we define the prompt variable by calling the from messages method of the chat prompt template class. We define the model variable by instantiating the chat OpenAI object. We define the underscore sanitize output method, and then we build a chain from prompt, model, an instance of str output parser, the sanitize output method, and the run method of a Python REPL instance. We can then call the invoke method on the chain by passing the input what's 2 plus 2, and we'll get the messages Python REPL can execute arbitrary code, use with caution, and we'll also get the answer, which is 4, because 2 plus 2 equals 4. Routing by semantic similarity. Using the LangChain Expression Language, you can easily add custom routing logic to your chain to dynamically determine the chain logic based on user input. All you need to do is define a function that, given an input, returns a runnable. One especially useful technique is to use embeddings to route a query to the most relevant prompt. Here's a very simple example. From LangChain, we import the chat OpenAI, the OpenAI embeddings, the prompt template, the str output parser, the runnable lambda, and the runnable pass-through classes. We define our physics template variable and the math template variable. We define the embeddings variable as an instance of the OpenAI embeddings. Then we define the prompt templates as a list containing physics template and math template. We then define prompt embeddings by making a call to the embed documents method of the embeddings variable and passing in the prompt templates variable. Then we define the prompt router method and the chain, which contains a dictionary with a query that we then pipe to the runnable lambda object, then to the chat OpenAI instance, and finally to the str output parser instance. We can then print the results of calling the invoke method on the chain variable and passing the what's a black hole question, and we'll get the answer. Using physics, a black hole is a region in space where gravity is extremely strong, so strong that nothing, not even light, can escape its gravitational pull. We can also call the invoke method again, but this time we're gonna ask a question that is more math related, such as what's a path integral, and we'll get the answer. Using math, thank you for your kind words. I'll do my best to break down the concept of path integral for you. In mathematics and physics, a path integral is a mathematical tool used to calculate the probability amplitude or wave function of a particle or system of particles. In LangChain Expression Language, you can also add memory. The following shows how to add memory to an arbitrary chain. Right now, you can use the memory classes, but need to hook it up manually. First, we do the import. From operator, import item getter. Then we import the chat OpenAI, the conversation buffer memory, the chat prompt template, the messages placeholder, the runnable lambda, and the runnable pass-through from LangChain. Classes from LangChain. We define our model variable as a chat OpenAI instance and our prompt variable by calling the from messages method of chat prompt template. We instantiate the conversation buffer memory object by passing return messages through, and then we call the load memory variable method on memory. We then try to build a chain from runnable pass, which we then pipe to the prompt variable and then to the model variable. Then we define our inputs dictionary containing the input hi, I'm Bob. We then call the invoke method on the chain variable and pass the inputs, and we obtain the response. The response is an AI message object with the content hello Bob, how can I assist you today? We can then call the save context method and pass the inputs and the output response.content attribute to it. And then we can call the load memory variable method on the memory variable, and we'll obtain as a result a dictionary containing a key named history and a value containing the human message hi, I'm Bob, and the AI message hello Bob, how can I assist you today? Then we can define the inputs variable as a dictionary containing input what's your name, and call again the invoke method on the chain using the new input, and the response that we'll get will be an AI message with the content your name is Bob. We can also add moderation in the LangChain Expression Language. The following will show how to add moderation or other safeguards around your LLM application. We import the OpenAI moderation chain, the OpenAI, and the chat prompt template classes. We define our moderate variable by instantiating an OpenAI moderation chain instance. We define the model variable by instantiating an OpenAI instance, and the prompt variable by calling the from messages method on the chat prompt template. We build our chain from the prompt and the model. We then call the invoke method on the chain, passing the input you are stupid, which will return the message you are stupid. We can then build a moderated chain using the chain and also pipe moderate. In this case, if we call the invoke method on the moderated chain and pass the you are stupid input, the output would be text was found that violates OpenAI's content policy. You can also use tools with runnables pretty easily. For example, you can pip install DuckDuckGo search. You can import the chat OpenAI chat prompt template, DuckDuckGo search, run, and str output parser classes from LangChain. You can then instantiate your search variable as an instance of DuckDuckGo search run. You then define your template variable, your prompt variable from chat prompt template, and the model variable from chat OpenAI. You define your chain using the prompt, the model, the str output parser instance, and the search. And finally, you can call the invoke method on the chain by passing the input I'd like to figure out what games are tonight, and you'll obtain the answer. What sports games are on TV today and tonight? Watch and stream live sports on TV today, tonight and tomorrow. Today's 2023 sports TV schedule includes football, basketball, baseball, hockey, motorsports, soccer, and more. Watch on TV or stream online on ESPN, Fox, FS1, CBS, NBC, ABC, Peacock, Paramount Plus, Fubo TV, local channels, and many other networks. The agent's dynamically called tool. The results of those tool calls are added back to the prompt so that the agent can plan the next action. Depending on what tools are being used and how they're being called, the agent prompt can easily grow larger than the model context window. With LangChain Expression Language, it's easy to add custom functionality for managing the size of prompt within your chain or agent. Let's look at a simple agent example that can search Wikipedia for information. We pip install LangChain Wikipedia. We import item getter from operator. We then import agent executor, OpenAI functions, agent output parser, chat OpenAI, chat prompt template, messages placeholder, chat prompt value, Wikipedia query run, Wikipedia API formatter, classes from LangChain. We instantiate our wiki variable by creating a Wikipedia query run object and passing to it a Wikipedia API wrapper object. We then instantiate our tools list that will contain the wiki variable. We then proceed to instantiate our prompt using the from messages method of the chat prompt template class. Then we create our LLM variable by instantiating a chat OpenAI object. Let's try a many-step question without any prompt size handle. First, we create the agent variable that will hold a chain formed out of a dictionary with the keys input and agent scratchpad that is then fed into the prompt variable, then into the LLM.bind method output, and then into the OpenAI function agent output parser instance variable. We then create the agent executor variable by instantiating an agent executor object. And finally, we call the invoke method on the agent executor with the input who is the current US president, what is their home state, and so on. Then the output is generated, entering new agent executor chain, invoking Wikipedia with list of presidents of United States. And then it goes for a series of pages until it reaches the page about Joe Biden, the current US president, on Wikipedia. Then it goes to the page presidency of Joe Biden, then family of Joe Biden, then cabinet of Joe Biden, then the page Delaware, then the page for Delaware City in Delaware, then Delaware River, then Lenape, and finally University of Delaware. And we get a response, bad request error, error code 400, message. This model's maximum contact length is 4097 tokens. However, your messages resulted in 5478 tokens. Please reduce the length of the messages or function. So unfortunately, we ran out of space in our model's context window before the agent can get to the final answer. Now let's add some prompt handling logic. To keep things simple, if our messages have too many tokens, we'll start dropping the earliest AI function message pairs. This is the model's tool invocation message and the subsequent tool output message in the chat history. We'll create a method condensed prompt, then we'll create our agent chain with the dictionary, with the keys input and agent scratchpad that is then fed into the prompt variable, then into the condensed prompt variable, then into the output of the LLM bind function, and finally into the OpenAI functions agent output parser instance. Then we create the agent executor by instantiating an agent executor object, and finally we call the invoke method with the input who is the current US president on the agent executor variable. Once again, we go through a series of Wikipedia pages until we reach the University of Delaware page. And in this case, we have a valid response with the input who is the current US president and the output. The current US president is Joe Biden, his home state is Delaware, and all the additional information that we've requested.